traveling the mountains just to find the loudest seas. We set down by the fire, knowing we could aim higher, but we didn't know that yet. So if you want something to hold on to, gotta find it first. But here I am, 'cause I've been laying under palm trees, waiting for the summer, knowing there's nowhere to go. 'Cause I am happy on this island, wanna be my farmland. I don't ever want to leave, I'm in a tropic club. I remember the ocean, memories die out too hard. But we were traveling the mountains just to find the loudest seas. We sat down by the fire, knowing we could aim higher, but we didn't know that yet. So if you want something to hold on to, gotta find it first. But here I am, 'cause I've been laying under palm trees, waiting for the summer, knowing there's nowhere to go. 'Cause I am happy on this island, wanna be my farmland. I don't ever want to leave, I'm in a tropic club. I'm in a tropic club. I've come from far away, take me home, back to yesterday. With you I wanna stay, hold my heart, keep my love contained. I came so close to being there, my hopes are looking up, but can't see that far when I sleep without knowing. I know it's not right, but the night is calling, the night's calling me.
All right, and we're live on YouTube and on Teams. Very, very warm welcome to everyone joining for our first TUM.ai AI E-Labs version in cooperation with the KNUST University in Ghana. Thank you all so much for joining. I'm very excited for this evening. Over the last 2 weeks, our participants have gone through a very intensive AI school and ended up with a lot of amazing use cases, solving problems in their local community, for example, in traffic, agriculture, or health. And all of that was possible through very, very cool organization from the TUM.ai side. We had the first call with KNUST, I think, about a month ago. And in that time, we organized a very spontaneous, but I think very, very cool bootcamp for our participants from Ghana. And I'm very excited for this evening tonight. We have 8 teams that were chosen as finalists from 450 participants initially. So we have the creme de la creme from participants from Ghana pitching to us today. I'm very excited to be joined by an amazing jury, who I will introduce later as well. First of all, I want to hand over to the professor from Ghana, Mr. Professor Jerry John Kponyo, who will introduce him and the university a bit more. Welcome, Professor.
Thank you, Leonard, for that good introduction. And hello and hi to all of you, my friends out there. When we began, we did mention that the days ahead were going to be very exciting, and within the period that we have gone through the process, it is evident that indeed it has been an exciting time. Indeed, here at KNUST, and I'm certain at TUM also, the theories and the principles that we learn are directed at solving the problems of society. And so, having gone through all this training and having come this far, I want to congratulate each and every one of you for having progressed through the training up till this time. For those who have an opportunity to showcase the works that you have done, I just want to congratulate you. Whether you end up as the winner or not, I just want you to know that indeed you are a winner, and I do congratulate you. I want to say that this particular initiative is the first of its kind, and I am certain that it is not going to end here, but beyond this particular collaboration, there are several other things that we can continue to do together. I want to encourage all the teams to stay focused, give it your very best, and I am certain that at the end of the day, all of us are going to come out as winners. So let's stay back and enjoy the pitch. Thank you. Leonard, over to you.
Thank you very much, Professor. I'm going to hand over to the TUM.ai president and founder, Toby. It's your turn.
Hello all together. I will present my screen. Second, can you hear me and can you see my screen?
Yes, we can hear you.
Okay, awesome. So as Leo already said, my name is Toby and I'm one of the 3 presidents of TUM.ai. And actually, I was already here 2 weeks ago to give a few opening words. And now for me, it's really, really a pleasure to be here again and to give the opening words for this final pitch day. And I'm really, really looking forward to all the results. And as Professor Kponyo already said, you are all winners because you already made it into the finals and you all learned about AI. That's also a key thing here. And so at the very beginning here, I will really shortly talk about TUM.ai, right? This will be a recap for you if you already heard that. But then I will also give you a few new words about why we actually host this AI Entrepreneurship Lab. So as already said, for those who haven't heard about TUM.ai so far, what is TUM.ai actually? So first of all, TUM.ai is a student initiative, and a student initiative in Germany is a club managed and led by students. And we are supported by the Technical University of Munich, therefore the name TUM.ai. Actually, we are also the leading AI student initiative in Germany. The second point, we are a non-profit organization, meaning that we are not profit-oriented like other companies. And the third point, we have a clear AI focus. Therefore, also the name, right? AI at the very end of our name. So we want to bridge the gap between theory and practice in the field of AI. And here are also some AI. So to make it really short, we have about 100 active, so actually really plus collaborations, for example, with Google, Microsoft, or IBM. We have 15 plus different majors. So we not only have technical backgrounds, we also have management or marketing students. Every year we get a lot of applications, and then we select the best motivated and highly skilled members which can join TUM.ai. Also, our initiative has a very high technical background, right? About 70%, but it also means that we have 30% with a non-technical background. For example, business students, domain experts like medicine students or marketing students. And also 70% are graduated students, so they are in the masters or even make their PhD. So these were the main key figures about TUM.ai. And now I want to also go over to the question, why do we also host this AI entrepreneurship lab? And this, of course, especially this version is all about AI for good. So why AI for good? And there are some reasons, or especially one main reason for this. So in developing countries, many problems exist which were already solved in industrialized countries, right? So the solution already exists, but it's not at the right place so far. And our job is it to bring it to the right place, and we don't even have to make completely new research, right? From a technical point of view, these are low-hanging fruits. And by doing so, by combining the guys who know the solution with the guys who know the problem, who are the problem experts, we can have a huge impact and help the country to step up from a developing country to a developed country by leveraging AI technologies. So this is really, really the long-term goal, right? Especially for one country. And why especially this collaboration between TUM.ai and the KNUST? So the students from the KNUST, like you have an excellent engineering background and you also have the domain knowledge. So you are actually the problem experts. You know everything about a problem. And we from the Technical University of Munich, we have the AI expertise, meaning that we know how to solve that problem. And by bringing them together, the two parties, right, the KNUST students and the TUM.ai students, we can solve the problems and have a huge impact. And thus, we enable the problem solution fit. And as Professor Carbonio already told us, this will be just the beginning, the very beginning, and hopefully also in the future, we can further collaborate. And what is quite astonishing about this project is that it was really developed in a very, very short period of time. And therefore, I want to thank you, the main organizers of this event. So this is actually a screenshot from a preparation call we had some weeks ago, but I really, really like it because this shows that, of course, it's hard work, but at the end of the day, we really enjoyed it, as you can see here in the picture. And on the top right, you can see Obeng. Obeng is one of your colleagues, and he actually initiated and started this whole project when he contacted us some months ago. And on the lower left, you can see Leslie. He took over the project from the Ghana side and did all the project management from the Ghana side and was our main contact person. And then there is David and Patty. So two team leads within TUM.ai, and they put a massive time commitment into this project. So that is actually really, really astonishing what they achieved as the project leads of this AI entrepreneurship lab. So they organized a completely new concept, right? So we haven't had any other concept like this before, and actually there are no resources on the web so far about how to develop such use cases in countries like Ghana or any other countries. So they developed a completely new concept. They sourced the workshops, the lecturers. They made sure that everything runs smooth. So thank you very, very much to the main organizers, David and Patty. And yeah, a big shout out. And of course, they were the main organizers, but they had a lot of support from other great people. For example, from Leo. He's the moderator today. He's also team lead of the venture department from Flora, partners and sponsors department, Alicia in our community department, from Daniel, venture department, Markus Böbel, probably one of the most active TUM.ai alumni, Leonard, streaming and marketing expert, also team lead, and Emily in the venture department. And also, of course, a huge shout out to Professor J.J. Cobonio, who made sure that we can host this project with the KNUST team and enabled this project. So thank you very, very much to all involved members from TUM.ai, but also from Ghana. And if you have any questions about TUM.ai, you can follow us on LinkedIn, you can follow us on Instagram, you can check out our website, or you can write us an email. Here you will find all the details. So thank you very much. I wish you all the best for your pitches. And yeah, then I will hand over to Leo again.
Thank you, Toby. And thank everyone for organizing this amazing event. Especially shout out to David from my side for the amazing collaboration. It's been fun, and let's have a great last event. Perfect. Let's come to the main part of tonight. We have 8 amazing teams pitching to us from all over the place. We have different questions, different domains. We are going to see a lot of exciting use cases, solving problems in the communities of Ghana. And I quickly wanted to talk a bit about how we are going to do this. So because of some internet issues we've experienced in the past, we asked the teams to pre-record their pitch. So we will show their 4-minute pitch, and after that, we will have a live Q&A session with one of the team members. We will start with one of the teams called Bandicot. They are focusing on road safety and how to make roads more accessible and more safe for everyone else. Also, before we start, just a very brief shout out to everyone else who participated in this week and who put a lot of work into their presentations, but unfortunately weren't chosen to be in the final. We really hope you still enjoyed the sessions and learned a lot, which you can take also further than in your studies. And yeah, I hope you're excited to see what your teammates did as well. So without further ado, I would suggest we start to the pitches. The first team up is Team Bandicot, and they are represented by Obed.
Hello, good day. Yeah, Team Bandicot reporting or presenting on the pitch for AI4Good, and we are presenting on an ML model for curbing road accidents. So there's a big problem of road accidents in Ghana. There are about 10,000 fatal traffic accidents that occur annually in Ghana, of which about 16,000 people die, or there are several casualties, and 15,000 are seriously injured. So this is a big problem that we are trying to address in Ghana, and the main reason why these accidents occur is because of the poor roads. Because the other hello, good day. Yeah, Team Bandicoot reporting or presenting on the pitch for AI4Good, and we are presenting on an ML model for curbing road accidents. So there's a big problem of road accidents in Ghana. There are about 10,000 fatal traffic accidents that occur annually in Ghana, of which about 16,000 people die, or there are several casualties, and 15,000 are seriously injured. So this is a big problem that we are trying to address in Ghana, and the main reason why these accidents occur is because of the poor roads. Because the other factors such as poor weather or negligence on the part of the riders or motorists or even pedestrians on the road. But the major problem is bad roads. Most of the roads in Ghana are unmotorable. So the solution we are giving for this AI presentation is we want to present a trained semi-supervised machine learning model that we'd use to solve this problem. So basically how this model would work is that first of all, we train the model to count the number of vehicles that ply on a particular road in a day, and then we use the data obtained from this model coupled with the data from the road constructor specification to be able to determine the load-bearing capabilities, and then based on the number of people or number of vehicles plying the road, we can find the force, the forces that are exerted on the road, and be able to determine how long the road will be able to last, so that you can predict when the road can fail, to be able to give the information to those appropriate authorities to come fix the roads. So how are we integrating AI into this project? Basically, the AI will use several trained object detection models, mainly the vehicles, to count the number of vehicles, yes, and predict the weight from the manufacturer's data set. So various cars would have, like, whether it's a Benz, it's a BMW, they will have their weight specifications. So the ML model will take that image and be able to compare it with the data from the manufacturers. Then the weight is used by the AI to determine the load or the force exerted on the road, and then be able to find the daily deformation rate, which can then be used to predict the lifespan on the road, right? And then the sections that are more likely to develop potholes. And this cannot be done in any other inexpensive means, whether like physically or using manpower, without using high amount of data. So the AI would be a good application for it. So what kind of data are we going to use? Most of the data will be obtained online, and the acquisition of this data would follow a legal process. So we follow all copyright and privacy laws. Basically, the data would be the images of the vehicles, what kind of vehicles, whether it's long tracks for haulage, saloon cars, and all. And this data will be obtained from the local government and construction agencies, right? And it will be used to determine the efficiency of the model. So how feasible is our project? The model can be deployed locally. Yeah, it can be deployed locally. So the model can always be maintained and continuously improved or upgraded. So the hardware we'll be using basically will be traffic cams and other surveillance cameras in the area. Local servers in especially Ghana would not be so strong, have the computing power to do this. Yeah, so, and then the app that we'd use would have an interface that can easily be interacted with by the user. Lastly, what kind of risk will we have? One thing is that the problem is that it may not be applied in rural areas. This is because there may not be traffic cams in rural areas. But the thing is that this problem you're talking about is not really happening in rural areas. You don't have a lot of accidents in rural areas, so this can be averted. And then there's also a possibility of our data being compromised. There can be hackers and all that. So this can be averted by using a high quality or good security system with good authentication for it. With the right and quality data, we expect that the model can be able to make about 80 to 97% probability of the predictions, right? 97% confidence. So most of the data will use be from the internet and then from local bodies and construction companies. Thank you very much.
Okay, thank you very much for that first pitch. I'm afraid the video was a bit broken. We checked and it's only going to be here. So you only saw one slide, but I hope you understood still what the team is trying to solve. One thing I forgot to mention, which I have to mention because they are one of the main stars of our pitch today, is our jury, who I first of all would ask to put on their camera so that everyone can see who we brought along. And I just want to quickly introduce all four of you because I'm very happy that you're all here. I'm going to start with our very own Luka Dombetsky, who's one of the oldest in tenure, not in age, oldest members of TUM.ai. He's, or you can see him on the right. He's been with TUM.ai since the beginning, is one of the mentors, is actually my mentor at the venture department and always here to help. Professor and Suleimana, it would be amazing if you could also turn on your cameras. Amazing. From Professor Ponyo, you've already heard. Thanks a lot for joining. Next up, we have Lucas and Veen, who's joining us straight from Copenhagen. Lucas studied data science and is an expert in data science and is deploying his expertise now at Pleo, a large startup focusing on B2B fintech. And he's joining there the CEO office with the strategy analytics. So also thanks for taking the time in your busy day to come and have a look at what we've been able to achieve. And last but not least, Suleimana Adams is also joining from Ghana. He's part of the KNUST COE Innovation Center, also closely related to the organization of our AI4Good initiative. Thanks a lot for joining. So now that you've all met our jury, we are going to try to reach Obed, who is the representative of Bandicot, for the quick Q&A. Earlier, he had internet issues. I am trying to see if he's here. Obed, if you are here, please show your video and unmute yourself. Okay, it seems like he is not here. Yep, that was the issue we had anticipated. But maybe the jury can still talk about what they have as questions to the team. And perhaps he joins in the meantime, and otherwise we move on to the next team.
Maybe I could start. I think first of all, it sounds very interesting, the project, to make something like that possible. And if you could really have feasible, like good data quality to make something like that feasible, I think you can really do something or like improve something. And also, as they mentioned in the video, there's thousands of people injured every year or dying. So that is really a nice use case, I think. And also, as mentioned in the video, I think it's also feasible that you obtain the data. One question that I had was more to the machine learning approach that was suggested, as maybe I just misunderstood it, but I didn't really understand the supervised learning approach in that, because that would entail that there was like data from maybe a different city or a different country where there was already a label on it saying this street is in bad condition now after so and so many cars. And I didn't really understand where the participants wanted to get that data from, or if they would just do some calculations and say like, okay, after, I don't know, 10,000 cars, this road would be broken. And then it would more be rather than a supervised machine learning approach.
Yeah, thank you, Lucas. I just checked and Obed isn't here apparently. So I would suggest let's move on to the next team. And I'm sure from the next team, we will also have a representative. Next team is Team Cheetahs, represented by Albert, and they are focusing on decreasing crime in Africa. So take it away, Team Cheetah.
Hello Team AI, this is Samuel from Team Cheetahs, and we are making an AI-based project on crime investigations in Ghana. Crime investigations in Ghana, security is so much cherished in Ghana here and even around the whole world. And what's better than having a secured environment around? And that's what Team Cheetahs want to ensure. Okay, so what's our problem anyway? Well, like I said, Team Cheetahs want to tackle crime investigation. What's the crime investigation that we want to tackle? These days, a lot of crimes are reported in Ghana, and few of them have their suspects or criminals arrested. Ghana has a whooping crime index per day. That's a lot of criminals reported per day. But still, where do those criminals go? Only a few are caught, and many are gone scot-free. You can't find them in Ghana, and that's the problem Team Teachers want to solve. Yes.
Hi guys, it's Prince from Team Cheetahs, and I'll be speaking on how and why it should be done with AI. So day in and day out, crime activities are captured with security cameras, and these videos can be inputted into the AI model, which you then match it with already inputted database. And we can get this database from the National Identification Authority provided we have a warrant. And this database is close to 100% accurate, because it's got from the Ghana cards, and about 83.4% of Ghanaians above the age of 15 already have their Ghana cards. So it's quite accurate. It's very accurate, yeah. And can it be done without AI? Yes, it can be done without AI, but AI is going to increase the efficiency of this investigation. So that's why I think this should be done with AI.
Hello, fam. Yeah, this is Queenie from Team Cheetah.
The technical visibility of this project, first of all, places likely to benefit from this system are the developed societies. Many more has to go into providing security cameras on streets and commercial centers of rural areas and linking them to. Additional computing power would not be needed that much. Just a central supercomputer with a lot of storage could handle the data from the NIA. Any update? Sure, why not? If there are better computing version system around, why not install it? And the last part is trained officials can be made to join the BNI and investigation department. And the whole model would be input data, search, match results, and output possible suspects. So like how we see the data is here, you search, you get it, and that's all.
AI model is perfect, so our AI might not produce accurate results as we would want. Accuracy might be off. This might produce wrong images sometimes, and also blur images from security cameras. Images might not be clear as we want them from security cameras, and also descriptions from persons as well might not be as clear for artists to make right drawings. And also Ghana is not a very developed country, so most parts of the country do not have cameras. This might be a problem. And also getting the permission from NIA to use their image data sets. This is a sensitive data, you might not get access to this kind of information as well. So these are some of our problems, and we have answers to them in our
Amazing. Thanks a lot, Team Cheetah. I really like the background music, making it a lot more fun to listen. Coming to the jury, and I see that Albert is also joining to represent the team. Jury, if you have any questions, you have 4 minutes to grill the team.
Okay. I have a few questions I want to ask.
Go ahead. And Albert, it would be amazing if you would turn on your camera. Thanks.
Okay, so regarding the approach that you want to use, the data that you want to use is not just limited to crime scenes. If you are going to be scanning through footage that has been taken on streets, there are other footages that are not really criminal in nature. How are you going to ensure that the rights and the privileges of such people are protected? How are you going to ensure that the privacy of people are protected in the approach that you want to use in fighting crime? I am more interested in ensuring that there is no abuse as far as the solution that offering is concerned.
our data comes from security cameras in very public areas in Ghana, like streets and hotel alleys, and privacy is not really infringed on in accessing data from this method, since the cameras are positioned in public areas, places like washrooms and washrooms don't have cameras due to privacy. So I think privacy will be really taken care of, because these security cameras are in streets, corners, and along roadside. So, and if a crime is reported at a particular location, we check the cameras and we scan the images of the culprits, and then we cross-check it with our data from NIA, which has images of all these people and their location, their height. So we can close down some of these data to have phone numbers, so we can even get access to all these, provided the NIA grants access. And I think the BNI too can help us in getting this kind of data, since it's going to help them in their crime fighting and increase safety in Ghana as well.
I would like to follow up on that. And that is that I'm a bit confused on what you want to train the model on. Do you want to have a model that detects people and then search with the database given a warrant? Or do you already want to train with the whole database of all of the Ghana people?
Yeah, it's a bit of both. We want to search with images we get from the crime scenes and send a warrant once we get a match. And also want to train a model that most of these pictures taken on our Ghana cards are, we renew them in a period of 4 years. So we want to train our model to be able to adjust to aging as a process. So maybe someone ages in a couple of 4 years, someone puts on makeup, someone changes the hairstyle. We want our model to be able to know that it's the same person. So that's where we want to train our model to in that aspect as well. Is that okay?
Perfect on timing. Amazing. Thanks a lot. Thanks a lot, Albert, for the pitch. Very excited to see what you've built. I hope you had a lot of fun in the last 2 weeks. And we will move on to the next team. Next team in line is Team Crime Detection, represented by Michael. And they are also focusing on crime.
Good afternoon. This is Team Crime Detection, and we are working on a model to detect criminal activities. With our previous statement, we have come to realize that per statistics from the Ghana Crime Rate and Statistics 2001 to 2021, crime rates in the form of homicide purposely inflicted as a result of domestic disputes, violent conflicts, predatory violence, and killing by armed groups have risen from 2.24% increase in 2015 to 8.49% increase in 2016 to date. So Team Crime Detection is basing on these statistics to develop an AI that only uses computer vision, that will not only use computer vision but also the use of text generation and sentimental analysis to reduce crime rate. So our program statement is the response time of the police department to criminal activities is not the best. In our solution, we will be using video feeds from surveillance cameras, which we will integrate with our AI model to detect actions related to crime. Some of these actions are drawing out of guns, knives, breaking into rooms, and all sort of that. And this is going to be a computer vision and image detection model. The model will be trained using data feeds from pre-recorded crime scenes to train and detect burglary and gun activities. Our data we are planning to get data from video feeds in the environments such as the streets and personal homes, people who have their own cameras installed around their homes, and also from offices, and taking data also from the national database system. How is AI part of our solution? With the AI, we'll be able to work with a lot of environments at once when we get data feed from different locations, because we have our AI model integrated into these cameras. we'll be able to simulate a lot of areas simultaneously. And this will be, the AI will be able to rapidly and accurately assess these areas, because this is a machine to be able to predict much faster than humans in the area. Then we have some technical feasibilities. So high resolution cameras are required for accurate AI detections and predictions. We will need cameras with high quality. We need a lot of computers to process that. Then we are going to generate text and alarms to alert the police in case of this happening. Then we'll be able to detect, to update our model to meet future demands, to new trends of criminal acts, so that we can train it to detect other crime activities as well. Then identities will be able to be uploaded automatically when we give that to the database. Then also we have some risks and limitations. So the videos may be distorted, resulting in loss of scenes recorded. Then images recorded might be distorted, making it difficult to identify the scenes. Then at night we might have poor visibility and all that. Then the inability of cameras to cover all the areas that we need to cover. Then we'll see that people too might steal some of the scenes, and that can free other suspects. And because this is data privacy, we are also working such that only authorized personnel will be able to access the videos. Thank you very much.
Amazing. Thank you very much. And again, we have 4 minutes for jury questions, and I would kindly ask the jury to turn on their videos again, and you can actually keep them on during the pitches as well.
I'm interested in the margin of error as far as your determination is concerned, mindful of the fact that the decision that you arrive at using the AI model puts somebody's life in a balance. What is the margin of error as far as your determination is concerned?
Michael, can you hear us? Michael Kokonu, I think you're in the call. You just have to unmute yourself and you can speak. Hello? Okay, it sounds like he has some connection issues because he's in the call and he's trying to say something, but it cuts off every time. Maybe give him another second. Hello, Michael? Well, I think if Michael, no, I can't hear you. Okay, I think still thanks a lot for the questions, Professor. It's a shame that the internet connection isn't supporting us right now, but I think we had a good overview of what the team has worked on, and I think again we have to reiterate that the teams started learning about AI only 2 weeks ago, and now are already able to come up with a use case of how to implement AI to solve one of their problems in their local community. So I think it's applaudable. And with that, I would like to introduce the next team, our 4th team, called Team Hexcon, represented by Emmanuel. Team Hexcon is focusing on the learning environment in Ghana and wants to build a smart learning assistant. So please, team, take it away.
Hello guys, my name is Manu Nyantichi Buahe, and I'll be doing the presentation for Team HESCOM. I would like to also use this opportunity to thank you guys very much for organizing AI4Good. It has been very helpful. It has been very helpful, informative, and very fun. Thank you guys so much. Now let's move on into our presentation. Okay. Yeah. So with my team, we centered our projects on giving students an advantage in West African exams. We plan to use an AI study assessment to ensure a more streamlined the West African Certificate Examination and the Basic Education Certificate Examination is one of the crucial factors in the pursuit of higher education in Ghana and the other African countries. Over 1 million students all across Ghana, Nigeria, the Gambia, and Sierra Leone are registered each year. In 2020, Ghana had a pass rate of 68.5%, Nigeria had a pass rate of 65.8%, the Gambia had 64.8%, Sierra Leone had 4.5%, which I think is actually very bad. So, and the causes of these failures, as published by WIAC in 2019, was due to poor learning habits and distractions that students encounter all around them. So with Don Long, me and my team from ESCOM on how we can help to better and improve our pass rates. Yeah. Then, so we developed a solution. HESCOM tries to create an educational platform in the form of an app that has various learning materials and most importantly, past questions that can be studied by candidates for these exams. And I'm going to be that the West African Education Council, which organizes these exams, often repeat past questions past questions for these. So I think if you have that and you provide students with that, I think it will help boost their performance. And this interactive app will guide students to learn at their own pace, which is I think it's very important in a streamlined manner by learning relevant topics. It also helps students cultivate a habit of consistent learning. So how is AI, what role does AI play in our app? How does it help make our app unique? Yeah, so HESCOM's unique solution uses data mining and clustering algorithms to gather information on the student's performance and learning habits as he or she continues to read and solve past questions on the app. Based on that information, topics and questions in the app can be recommended to the user. So, I think on our left, you can see a flowchart there. The data mining and clustering algorithms. For the clustering algorithm, we're going to do is we're going to use MK-based clustering, and those algorithms get information from the user. So when we get the user information, we can use it in to select topics and questions for the user to solve. Then we also plan to integrate a chatbot into our system. Then what the chatbot is going to do is it's going to recommend, it's going to give links to other educational websites, links to textbooks and everything. And it's going to be interactive too, and it can advise the user on what he or she should learn and how the person should learn, so that his or her performance can be maximized. And with chatbots, we fall under the category of natural language processing AI algorithms. So we are going to need packages from NLTK, which is a library for doing this. And I think to make our work faster and easy, we are going to import pre-trained models, for the chatbot, so that it can make it simple for us. Yes. Our model can be hosted on a cloud service and can be connected to the app through an API. So risks and limitations, and I believe that with any business with any venture, we experience this. And I think the main thing we face, we have to do with privacy. And for that, we are going to use our source privacy preserving clustering schemes that will help encrypt and secure user data when it's being uploaded to the service, to the cloud service. Then on a business perspective, with any business, I think we have to get some money, we have to get something to support and improve the business. So a premium package will be made where users will have to pay to get additional features, textbooks and past questions on the app. Now, what we plan to do, we want to help African students. So I think we will have to subsidize the price so that the average African student can get access to this. This is what we plan to do, and we hope you love it. You enjoy this presentation. Thank you very much, guys. Yeah, thank you. Bye.
Amazing. Thank you very much, Emmanuel. Now we come to the next jury session, and I think, Emmanuel, you should also be in the call, so please unmute and show us your video so that the jury can see you.
I have two quick questions to ask. The first one has to do with, in training the model, the answers to the past questions that you are using, how do you validate that they are accurate? That is the first one. The second one has to do with where questions involve qualitative answers. How do you deal with that? I know that for the multiple choice questions, it is easier to train the model to do that. But if it involves qualitative answers, how are you going to train the model, and how do you get the students to use that? So these are the two concerns that I have, if you can respond to it.
Emmanuel, you have to unmute yourself. Okay, it seems like the major issue for our friends, the internet connection between TUM, our Munich, and Ghana. I think Emmanuel is in the call, but he isn't responding.
The presentation, was it pre-recorded or is live?
Yeah, the presentation was pre-recorded because we experienced those kinds of internet issues, but we just tested before this and it worked out fine. But now apparently the internet hasn't worked for him. But I think the main value still lies in the presentation, which we pretty clearly saw. So I think we are able to judge from what we saw on how the team worked over the past 2 weeks. And I would suggest we move on to the next team. Maybe at some point we will have the opportunity again to speak to one of the participants live. But without saying more, let's go to Team Kangaroos, and they are represented by Edmund, and the team is tackling road safety. So please, Team Kangaroos and Edmund, turn on your camera, please, and Team Kangaroos, take it away with it.
Edmund, and I'm presenting on behalf of Team Kangaroos. We are working on fixing potholes using drones and autonomous vehicles. Now, in Ghana, we have so many roads that are covered with potholes, and this makes the roads inaccessible because of the inconvenience it creates for both drivers, pedestrians, and then cyclists that are commuting on these roads. To solve this problem, we are looking at using drones and autonomous vehicles to solve the problem. Now, what does the drone do? The drone will have an image processing capability so that it's able to scan and detect cracks and then potholes that are on a particular road network that we want to fix. And so after detecting those potholes and cracks, it provides us with dimensions such as the depth of the pothole, the width, and then the length of it. Now, this data set provided by the drone is fed into the autonomous vehicle or robot that is programmed to ensure that the road is fixed very well. So using this data set from the drone, the autonomous vehicle is able to inject the right amount of asphalt into the pothole and then the roller is able to compact it very well to ensure that we have an even patch on the road. Now, what role does AI play in the solution we are proposing? The role of AI is seen predominantly at the point where we are scanning and then detecting the pothole. So we see that computer vision and image processing is being used here. And in the end, we are expecting that the solution we are proposing will help in decreasing the maintenance costs, since we will not have to employ so many laborers to fix the potholes on a particular road network. And also, the work done by the robot will be much more efficient than that of humans. And so we are expecting that the roads will have a longer lifespan after fixing them. Now, the source of data will obviously be the drones, and then the drones pictures and then videos, that is scans. And then our data set is not noisy. For technical feasibility, the model for our solution will be deployed in the software for the image processing used by the drone. And so we'll need computational power for that software to be able to work properly. And also, the user does not need to directly interact with the model. All the user needs to do is to pilot the drone on the road network, on the road, for it to do its job. And then anytime we need to roll out any updates for the model, effectively, it means that we need to update the software that is running the model. Now, potentially where we could have limitations would be when the software that is using the model malfunctions, which may end up giving us false positives. So it will see a pothole and not identify it as one. And so to fix this, we are looking at providing a test mode for the drone, so that before it is used to do the work that is intended for, we are able to test it to see whether it is functioning properly. And when we do that, it means that when it's working properly, we'll be able to use it successfully, and then we'll not have any false positives. Thank you very much. And this is Edmond presenting on behalf of Team Kangaroos.
Amazing. Thanks a lot, Edmund. And I see you are also with us and your connection seems to be stable. So I'm very excited that we will again ask the jury for their feedback and their questions directly to Edmund.
My question has to do with you want to take a picture of a pothole, and then on the basis of the picture, you want to train an autonomous vehicle to be able to fix the pothole. My question has to do with what information are you using to train the autonomous vehicle with reference to how much asphalt has to be put into the pothole to be able to fix it? Where are you getting that information from to be able to train the autonomous vehicle to do same?
Okay, thank you very much, sir, for your question. So, with the drones, the drone is going to do the main AI part of the work, which is scanning, and then with the image processing capability of the drone, we are able to get the dimensions of the pothole that we want to fix. Okay, so when we get those dimensions of the image or the video that is taken by the drone, now those are the data sets that we are going to use to train them. Those are the data sets that the autonomous vehicle is going to work on. So now when the autonomous vehicle gets on the road, we also have the coordinates of those potholes saved. So when the autonomous vehicle gets on the road, it has been programmed already that, okay, on these coordinates, we have a pothole of this nature here. This is the depth. And so we know that okay, for a pothole this deep, this amount of asphalt is needed to fill it. So I hope you've gotten my answer.
Because you need to provide the autonomous vehicle with some information with reference to how much asphalt has to be deposited. I thought there was AI involved in that aspect as well. I didn't know the AI was only limited to the drone side.
Our solution is the AI part of our solution is mainly focused on determining the nature of the pothole, so that now a program is written for the autonomous vehicle to use in addressing in fixing the pothole. So now having the coordinate of each pothole as part of the data set that is given by the drone and from the image processing, that is what the autonomous vehicle rely on to fix the pothole.
Okay.
Yeah.
I have a question.
Okay.
Yeah, so why did you decide to deploy the AI onto the drone? Since what you need for the ground vehicle is just the coordinates of the potholes and the depth and all the other parameters to be able to fill it well. So why did you decide to deploy the AI onto the drone instead of probably capturing the videos and images and then processing them on some workstation or a ground station? So why did you decide to deploy the AI on the drone?
Okay, so we decided on the drone because the drone will be much more less costly in deploying drones, and then it makes assessing the road easier. It doesn't obstruct any traffic. It doesn't cause any problem to anyone accessing the road at any point in time. And also using the drone makes it easier for us, because now if the drone has with the drone having the image processing capability, everything will be real time, and then it's able to also capture the coordinates for us. So we don't need humans to come and now be taking cameras or footages that may not give us the results that we desire at the end.
Yeah, my question is not really about the humans. Okay.
I think time is up for now, but
Yeah,
thanks a lot for your
no problem.
questions, and thanks a lot, Edmund, for your answer. Great pitch. I'm
You're
looking
welcome.
forward to seeing the next team also focusing on road safety. Next up is the team Pangolin, represented by Stefan. So Stefan, please open your camera, and then we can see you after for the Q&A.
Good day, everyone. I hope everyone is doing fine. We are Team Pangolin. And the problem in Ghana we seek to solve with AI is detection of misconduct on our roads. Misconduct of drivers on our road have led to an estimated 2,000 deaths from January to September 2021 from information from the MTTU. These misconducts include overspeeding, parking at wrong places, and sometimes the failure to adhere to traffic lights by especially motor riders. And law enforcers, they are limited by their resources and their number. So it's sad that they are not able to detect all the culprits. With our solution, we want to check the adherence to traffic lights, and we want to do this by mounting cameras at vantage points to check the speed and the adherence to the traffic lights by comparing that information to a training data set. Our main solution will include the anomaly detection, which will be used to identify offending drivers.
Now we'll talk about the role of AI. Now we'll be using AI to solve this problem. And a branch of AI we'll be using to solve this problem is deep learning. Now under deep learning, there's something we call semantic segmentation. Now this basically is able to identify the different objects, to be able to identify if this is a vehicle moving, if this is a pedestrian, if these are road signs here. We'll be able to we'll be using this in our solution, and also number recognition machine learning models that will be able to pick up the registration plates of the various cars, especially those that fault are found fault in here. Now, AI is very important to this because our human resource, the human resource of our law enforcement agencies are very limited. So that AI will just help them in their operation. Now, for our data sources, we'll be using video footages and images of what we think driver behavior should be at certain times. Now, accelerometers also will be used to measure the speed of oncoming vehicles so that we'll be able to determine whether they are within the speed limit. Also, the machine learning model, we're able to recognize road signs. We're able to train the model to recognize road signs. Thank you.
Solution is feasible in that it can be implemented with cameras and accelerometers, and so the cameras will be there, will be advantage points on the roads to capture the drivers of the cars as they pass by, and the accelerometers will be used to measure the speed of the incoming or oncoming cars. And so with this information, we'll be able to compare to know if these drivers are going according to conduct or not. And so with the risks and limitations according to in this solution, so the pose may rise as time goes on. And then also as we are capturing the images of the drivers, we are conscious of data protection. So we will be sure not to process the data that we get from this in any way without the permission of the person.
Amazing. Thank you very much. And we will go to the next Q&A session. And I see we have the representative from Team Pangolin here as well. Stefan, please unmute yourself, and then we can start with the 4-minute Q&A from the jury.
Awesome. Great pitch. I have a question regarding the traffic lights versus you want to detect also road signs. Why did you go for road signs as well? Like, I get the camera that looks at the road, but don't you know when you set up the camera what speed limit is there? Or why do you need this road sign detection?
You're muted still. You have to unmute yourself, please. Yes, and now exactly next to the video button is the microphone button to unmute yourself. Okay, I think like you could keep trying. Maybe you find the there's the button with the microphone next to the camera to speak. Maybe in the meantime, while we don't have sound, the jury could provide the team with a bit of feedback instead of the questions. What did you like about the presentation? What would you think should be the next focus area for them?
I think that the solution should be situated within a regulatory framework. Within the country, there are regulations with reference to how people drive on the roads. And it's important that if you are developing a solution, you do not ignore the regulatory framework. so that if the system is trained with the regulations in mind, automatically it should be possible to identify when people have flouted the rules. But it's important that your solution takes into consideration what regulatory framework is there as far as using the road is concerned. That's what I want to say.
Perfect. Thanks a lot for your feedback.
Maybe one more feedback from my side, just quick. I think also when you just put the cameras on the side of the street, there will be a lot of footage that will be captured without any real use case. If you if you just film the whole environment, so then also data, like the size of the data, could be a problem. And furthermore, also again, privacy issues. I mean, obviously you don't film a person, but rather like a vehicle. But still, there could be issues with the number plates and stuff like that. That might also need to be considered. Maybe adding to the regulation part.
All right. Thank you very much. Thank you, Team Pangolin. I assume, I don't think you unmuted yourself so far, but thanks a lot for your presentation. Thanks a lot to the jury for the questions. Next up is Team Sanitas, who are looking at applications of AI in healthcare. And the Team Sanitas is represented by James Owusu. So please, James, turn on your video so that we can see you. And Leo, please.
Team Sanitas. This is a multi-class classification model for a healthcare monitoring and alert system.
Our problem statement. In Ghana, the doctor-to-patient ratio is alarming. Approximately 1 doctor to 1,000 patients, according to the Ghana Health Service. As a result, doctors are barely able to give the right amount of attention to patients during ward rounds. This inevitably leads to late discovery of severe clinical events. Now, our idea summary. Our solution is focused on early detection of illnesses. Additionally, we also aim to make big-scale predictions which can prevent these outbreaks in the first place.
Why we chose AI. So due to the high number of patients and then low number of doctors, there will always be a lack of human resource. So the AI takes the work of the doctors and then it's taking the live data from the wearable devices on the patients. So it's able to classify the patients according to the data fed to the model. So in case of any emergency situation, the doctors are alerted quickly and then they're able to put a stop and to see to the patients.
Data collection and processing. So the data we will need for this system can be obtained from health monitoring systems. For example, wearable wireless devices like bracelets with sensors that will be able to monitor vital signs like heart rate, blood pressure, and so on. We can alternatively get this data from public access intensive care unit databases, such as the MIMIC2, or clinical sites for technological developments, those that comply with the relevant data regulations. When we are dealing with the data from the patients, we need to go through a series of processes to be able to utilize this data. The first is the data de-identification. We want to remove sensitive patient data, for example, the name, the address, and overall the identity of the patient so that it will not be made accessible to the public. The second process we need to go through will be the data curation. So it involves vital actions like the data management, modification, verification, extraction, and reproducibility, so that you'll be able to convert the collected data to our desired formats and also detect inconsistencies with the gathered data, store the data, and then we'll be able to now have the data classified to be able to train and validate the AI algorithm.
Feasibility and resources needed. Our model is deployed to the cloud to save costs of local installation and processing large amounts of data efficiently. Our model is deployed on web services such as Amazon Web Services. This allows us to process large amounts of information effectively and quickly without having to buy more equipment as compared to when it's done locally. Real-time predictions are used since health issues are quite sensitive. Our model is being used in health issues, we need our predictions real time so that the doctors can um, uh, react fast. An application software updating each user profile with vital signs for the monitoring devices and feeding that into the model for predictions. The system then sends a notification to the doctor for the doctor to react and treat the patient.
In conclusion, our solution seeks to help doctors to effectively monitor patients and eliminate the issue of late discoveries of issues which lead to death. Thank you.
Again, thank you very much for your pitch, Sanitas. And we have James Owuzo with us from Team Sanitas. James, could you please open your camera and unmute yourself so that we can hear and see you properly?
Hello.
Perfect. I can hear you.
Hello.
If you now also put on your camera, we can also see you.
My camera is on.
Okay, then jury, please, your questions.
I'll be glad. Okay, Lucas, go ahead.
Thank you. It's a short one. How will you make sure to collect the data? As I could imagine that a lot of patients wouldn't like to have the data collected from the health systems. And also, I think in a lot of hospitals, the devices are not yet so equipped to share the data to like a database, but it's more for monitoring. So how would you make sure that you can access the data?
Please, can you come with your question again? If I get you correctly, you said, how are we going to get the data to train the model? Please, is that a question?
Yes, exactly.
Okay, so there are websites that actually have data sets, medical data sets, and that's where we'll be getting our training data from. And these websites, they follow all the rules that are needed to make sure that data is secure and privacy is on point. So that's where we get the data. First, we did identify, that is, we remove the names and other addresses, other key and sensitive information. Then using that data is what we'll be using to train our model so that we don't invade anybody's privacy. Yes.
Okay. My question borders on securing the data because the information based on which the decision is made, if it is in error, could lead to a loss of life. So how are you able to ensure that the data based on which decisions is very well secured and it is accurate?
So real time, when the system or the AI model is working, it will be picking this data from health monitoring devices that we use in the hospitals already. So there are ones for pulse rate, others for temperature, others for blood pressure and all. So getting the data from these, that is what our AI model will use to predict the condition of the individual, whether they are normal, approaching critical. So if it's approaching critical, the app will tip off the doctor that particular patient is approaching critical condition. So quick measures should be taken. And moving on for long term, we plan on implementing the AI will be able to predict to the doctor some measures to mitigate what is happening very quick. Maybe the doctor, with human beings, you have to think through things a lot. But the AI, moving on in the long term, will be able to give a very quick action or suggestion to the doctor to easily mitigate the situation. Yes.
We would have time left for one more question from the jury. If that's not the case, thank you very much, Team Sanitas, for joining and presenting your amazing pitch. And we can move on to the last pitch of today before we have our break. The last pitch comes from Team Zaolas, represented by Samuel Donkor. And Team Zaolas is focusing on how to prevent, cure, and find diseases in Ghana with a special focus on malaria. So please.
Every minute, a mother, a father loses a child to malaria. Malaria is a preventable vector-borne disease that can cost as low as €1 to treat. But accurately detecting and distinguishing malaria from other diseases, especially less severe malaria from severe malarial infections, remain a challenge, mostly in rural, low-resource settings in Ghana, where there are very few health experts and facilities. Our solution seeks to automate the tedious process of reading hundreds of thin blood smear slides of malaria, making it easier for health workers or microscopists to diagnose malaria. The location where malaria was diagnosed will be geotagged and analyzed together with climate conditions to monitor and predict malaria outbreaks and breeding sites. We intend to leverage TinyML to build a smartphone-based machine learning system that will be able to diagnose malaria in a cheaper and easier way without an internet connection and low processing power. In rural areas where microscopes do not exist, we intend to couple the AI system with a 60x clip-on microscope, which will be able to analyze the thin blood smear of malaria and output a prediction.
Perfect. Maybe I'll start again. I have again a question regarding the sourcing of data, because I think the product that you showed in the end looked very promising, but obviously you also need these like microscope images to eventually classify the data. The images. How would you do that? For example, as you mentioned, there are some areas where you don't have any microscope. How would you get the images to be classified?
Okay, so for our data is actually coming from an open source health agency known as the National Library of Medicine. So it is a reputable medical research agency, and we can actually So they provide thin slice mesh of malaria, which are actually taken by microscopes, right? So they are like slices of malaria which are captured with a microscope. Then they are prioritized. They are categorized into two. So we have uninfected slides and we have infected slides. So our approach uses a deep learning model to predict if a slide is prioritized or it is uninfected, right? So in a place where there is no microscope, we want to utilize a no-clip microscope. That is a very small microscope that can be clipped to the back of your phone, right? That can be used to take the pictures of the slides. So the main question is, where is our data coming from? So data is coming from a reputable medical research agency that's known as the National Library of Medicine. Yeah.
Thank you.
Okay, I also want to find out, how does your solution prevent malaria?
Oh, okay, so in the eradication process of malaria, we are actually looking at three processes. So one is detection, and then the second one is cure, and then the third one is prevention from the first place. So we are right now focusing on prevention in the first place. So we use satellite images from maybe Sentinel-2 or maybe from other satellite sources, right? And then we detect malaria. So maybe during the summer, malaria is more prevalent at this place, or maybe during the spring, so and so forth and so forth. So we are using a machine learning model to predict in correspondence with the climate data. So maybe moisture or wetness, and maybe humidity, and then maybe temperature, and maybe closeness to water bodies as well.
Thank you. We have time for one more question.
Okay, I have a question. So, yeah, this is something I'm curious about. How did you come to a conclusion that malaria is difficult to diagnose? Because I know maybe in other countries where it is like a rare disease, where they don't usually get much contact with that, it might be a problem. But somewhere in Ghana where malaria to some extent is like very prevalent and frequent, and almost everyone has at some point in time gotten malaria in his life. So how do you come to that conclusion that malaria is like difficult to diagnose? I'm just curious.
Okay, so what we actually focus on is the expertise. So as compared to developed countries, in developing countries, there's no such expertise. And when you look at rural areas, for example, you see Ghana is not just a developing country. There are places where hospitals are not available, and then the distance to the hospitals are very long. Said that by the time you get to the hospital, you're already sick, right? And so we are using this approach because in this approach, we can utilize the different model to predict. So in the absence of maybe a healthcare worker, we have the slide there, and then anyone at all can use the model to predict maybe if malaria parasite is present on the slide or not.
Perfect. Thank you very much, Sam. Great pitch last 2 weeks. I hope you learned a lot. And with that amazing last pitch, we conclude our 8 pitches, and we come to the final part of our pitch day. So first of all, thank you very, very much for all the teams participating and sending us their applications and sending us their pitches. Of course, we had to select only 8, but the others were at least as good as they were shown here. So thanks a lot for everyone for the hard work. Unfortunately, we experienced, as you realized, a couple of technical issues, which we will from our side also take as a learning for next time. And it seems like Germany and Ghana have to work on their internet connection. But for now, I think everyone is ready for a short break. I would ask the jury, please, to join me in the jury room, which you can find on your PDF briefing. And then the rest of the participants, please have a 10-minute break and be back at 6:40 or 5:40 Ghana time, please. All right. And we are back from the break. Sorry for the slight delay. We had a long and intensive discussion in the jury room, and we came to a conclusion which I think no one took lightly. But I think we've seen a number of great pitches with amazing use cases, even some prototypes which will definitely solve problems in your communities. And from TUM.ai, again, we really hope you enjoyed the last 2 weeks of learning and building together. I hope we could provide you with a lot of new knowledge, especially throughout our AI helpers who were by your side the entire process. And now, as a next step, I want to hand over to one of my colleagues who was the main motivation and drive behind organizing this whole event. He slept a lot less than he used to, and I think he really deserves a couple of days of break after we finish here today. And yeah, with a virtual round of applause, I would like you to meet David Podolsky from the TUM.ai team.
Thank you very much, Leo. Yeah, as Leo said and Toby said, with last event, I would say we spent a lot of time for preparing, but it was extremely time consuming. Yeah, so I would like to present to you some slides before we are going to continue with our winners. If you give me a second. I hope you can see my screen. Right?
Yes, we can hear you and see you.
Cool. Yeah, just to be sure. Sometimes takes time. Yeah, I don't know. Do you see my screen, guys? With my slides.
Yes, we hear it and see it. All good.
Cool. I'm not sure actually. Give me a second. Yeah. For some reason, it doesn't want to show the Chrome here, which is quite bad. Yeah. Yeah. So yeah, I want to really say thank you to all the organizational team, especially Leo and Paddy for organizing amazing weeks, education week, venture week, and pitch day, which we are having today. Initially, we had 450 students, like Toby already mentioned, and we were quite excited for this amount of people because we didn't think we could handle this properly. But as you can see right now, we had over 700 views on YouTube already, one guest lecture from Google, and already 50 students who participated during the pitch day and venture week. So yeah, I also want to say thank you to our amazing AI helpers team. Without them, it would be impossible to prepare you guys for the pitches today. They spent a lot of time to give you all the needed information that actually help you to develop this concept that you have presented us today. Especially thanks to Flora for doing an amazing work for preparing the second lecture, which actually helped a lot of people. And yeah, Paddy, who's not on the slides here, but yeah. Yeah. So now, before we actually go to our winners, oops, yeah, yeah. I want to present the awards we have for them. So the first award would be the initial budget for idea realization. The second award would be our public announcement on our social medias like LinkedIn and Instagram. Third of all, we will have mentorship from TUM.ai members, which will help develop and ideate even further their ideas. And last but not the least, we'll have our podcast. They'll have their podcast session with us. So yeah, without further ado, I will want to present our winners. Team Saulas. Yeah, congratulations to you. You did amazing job. We really enjoyed all of your pitches. But yeah, we had to choose the winner. So yeah, I think I'll handle back to Leo, and I will see you around.
Thanks a lot, David. And also from my side, Saolas, you weren't the last, not only in the last team, but also from the jury voted as the best team. I think that, again, deserves a very, very big round of applause, even though we're not here all together in the room, but on Teams right now. But thanks a lot for your pitch. Leo, if we could go to the slide to see our winners, that would be amazing. Otherwise, quick comment also from my side. I think the discussion in the jury session was very intense, and we actually had a couple of teams very eager and very close to the win. So we don't want to share the close race on second and third, but rather focus on why Saolas won in the end. And yeah, maybe someone from the jury can give a bit of reasoning and feedback on why they think Team Saolas deserved this win today.
Yeah, I think the solution that Saolas presents is a very relevant solution as far as the community within which they are presenting it is concerned. And a lot of thinking went into the solution and its modeling. And the good side also is that they even have a prototype to show. So when it comes to implementation, we don't have so much of a difficulty. We can be able to pick it from where it is and be able to upscale it. And so I think that is what went into arriving at a decision as far as Team Saolas is concerned, coming up with a relevant solution and ensuring that when it comes to implementation, there isn't so much of a difficulty because they have a prototype. Thank you.
Amazing. Sam has also turned on his camera, so congratulations also from this side to the entire team, even though Sam, you're now alone here in the call because we couldn't invite all of your team members because otherwise our system would break down. But I really hope you learned a lot in the last 2 weeks. Maybe you can talk a bit about your journey, how you've experienced the last 2 weeks, and maybe also how you came up with the idea and what you think will happen in the future.
Okay, sure. So first of all, I'd like to thank the coordinators for this program, TUM.ai, and then also Professor. And I also would like to thank my teammates because they were of great help in this idea and the prototype of this. So that moving forward, see that malaria is eliminated once and for all as it was done in the Western world. So we are very grateful for this opportunity, and we also want to see that this project scale, that it is beneficial to most people, especially in the rural areas. Thank you.
Thank you very much. Amazing. Again, congratulations, Team Saola and Sam. I hope you can pass on your congratulations in person to your team soon. From my side, I would like to thank everyone for tuning in today. Even though we had some technical issues relating to the internet connection, I think we had quite a fun evening, at least I had. Thank you once again to our 4 amazing jury members, Professor Ponyo, Lucas from Pleo, Sulemana Adams from the Innovation Center, and Luca from our own very TUM.ai initiative. We come to the end from 2 amazing weeks of learning and working together. We hope you enjoyed it. We hope the participants learned a lot. The next steps for us will be to evaluate and to see how we can provide AI for good to even more communities around the world. We are already speaking to a couple of potential other partners in addition to KNUST in the future. So thanks again for being our first pilot partner for this. We enjoyed working with you a lot and hope to see you all very, very soon, either in person or again for the next workshop or iteration of AI4Good. So without further ado, thanks very much for everyone for joining. We had an amazing time and I hope you enjoy your evening now. Thank you very much.